With graphs, we often want to find the domain and range. This will help us determine what are possible inputs and what are possible outputs for our function. There's going to be a few different ways that we can write these, so I'll go through them as we look at these different graphs. So domain is all about x and what are the possible values for x, and then range is all about y and what are the possible values for y. So in this first example here, what you'll notice is that the graph is these separate points, so they're not connected at all. So what we're going to do is create a set of numbers. So domain will be a set of numbers, and we'll just write down the possible x values. So -3, -1, 2, and 5. So that would be our domain. For range, we'll do the same thing. We have -3, -2, and we'll just write that once. We don't need to repeat the values, so even though -2 shows up twice, we're just going to write it as part of the range once, and then 4. So in thinking about domain, I think of scanning along the x-axis, and going left to right will really help. So I start over here at like -infinity, and I'm looking at where are my x values. Okay, x equals -3, -1, 2, 5. Then for range, I'm thinking of scanning up and down along the y-axis, and I start down at the bottom at negative, and then I'm just scanning up. So we have -3, -2, +4. So we're just seeing along those axes, where do we have values that are defined. For this next example here, I'm going to do that same idea of scanning. I'm going to put in a little notation too. And there are a lot of different ways to think about domain and range. So if you have a method that you're used to, absolutely keep using it. I'm just going to show you how I like to think about it. So let's say we're working on our domain. So I want to think about kind of being out here, and I'm going to start walking to the right-hand side until we start having values defined. What we'll see is it starts at -3. In fact, we have a solid circle at -3. And then we have our function, we have our function, we have our function, until I get to +4, and then my function stops being defined. So what I mean by drawing this is that for each of these x values on the axis, I have a value that I could graph with the y-coordinate. But with domain, I'm only focusing on x. So with that, I'm just kind of ignoring y right now. So with this, I can see this number line where we're starting at -3 and going up to 4. So I could write for domain that x is bounded between -3 is less than or equal to x is less than 4. Again, with the solid circles, you'll have equality. With the open circles, it's not actually defined there, so we would just not have equality. The idea being that this function's going right up to 4. It's like it's at 3.9999999, but then at 4, it's not actually defined. So this is one form of notation that we could use. Another form is interval notation. So we could use brackets. Of using a square bracket means we have the equality, so -3, comma, 4, and then we would use parentheses for when we don't have the solid circle. No equality there. So I'm going to show you these two forms as we go through the problems here. Sometimes with online homework, it'll specify which form you want. I'll just show both. You can use whichever you want. It's good to know and understand both. Okay, for range, I'm going to do the same thing, but along the y-axis. So I'm going to imagine that I'm starting out here at -infinity, and then I'm going to start walking up the y-axis and just paying attention to when is our function defined. And it starts at -4 with a solid circle, and then the function's defined, it's defined, it's defined until I get up to +2, and then I have that open circle, and then I don't have my function anymore. So in this case, I'm kind of ignoring x, but it's the idea that I can map to my function all along the y-axis if I wanted to. out to the function. So with this one, we have equality at -4, and then it goes up to +2, but does not include +2. So what that would look like is it starts at -4, is less than or equal to y, is less than +2. Or in interval notation, -4 up to +2. But parentheses, because we don't have equality there. All right, let's go through a few more examples with these, because it just takes seeing it a lot of times to get it. Okay, for my x-axis here, so figuring out the domain, what I can see is even if I'm out here at -infinity on the x-axis, our function's going to be defined. It's going off forever to -infinity. And then if I keep walking along here, we're all good, we're all good, we're all good. And then it also goes off to infinity on this right-hand side. So x is going to go off to +infinity. What this is showing me is that x is defined absolutely everywhere. So something you might see sometimes is x is all real numbers. Or some notation that's used is x belongs to, and then the notation for the real number set. So maybe you've seen those forms before. Using inequalities, I could write it as -infinity is less than x is less than +infinity. Again, when you're working with infinity, you'll never have equality because we can't actually define what infinity is. So with that, we can't have it equal there. In interval notation, I would write this as -infinity to +infinity using parentheses. So that's domain, and that's about 4 different ways to represent the same thing. So if you're writing a written assignment, you could write any 4 of those and it would be correct. All right, for the y-axis, what I can see is it's not defined everywhere, because if I start out here at -infinity, I don't have any function to map to until I get to -2. So at -2, my function starts to be defined. I'm going to have equality there because I have a coordinate. And then it's going to go off and be forever defined off to infinity. So with this, I could say -2 is less than or equal to y. You could leave it at that. Y is more than or equal to -2. That's an accurate statement. If you want to see infinity in there, you could say it and then it's less than infinity, but that's not necessary. But if you do interval notation, we do need to have infinity in there, that we start at -2 and then we go off to +infinity. All right, this next case with a step function here. So I'm going to start out here at -infinity, and I don't have a function until I get to -2. Then my function starts, and it's defined there, and it's defined. And then at 2, what I just want to take note of is it's not defined up there at +3, but it is defined down at -2. So I can just keep going across that, and that's all good. So I don't have any gaps, even though sometimes this might look like a gap. The fact that we have a solid circle down there makes it defined continuously. All right, so for domain, we're starting at -2 is less than or equal to x is less than or equal to +8, or square bracket -2 +8 square bracket. All right, for y, we're going to see nothing, and then we're defined at -2, but then nothing. So we don't have anything until we get to +3. So even though y isn't defined at this circle, all through here we have y equals 3. So what's happening is there's only 2 spots that y is defined. So we could just make a set of -2, +3. Or you could write it out, y equals -2 or y equals +3, something like that, of where we just have these specific points where it's defined. Okay, two more examples here. This is a rational function that we're seeing here with these kind of gaps. So we can see there's this gap at y equals positive 1. There's also a vertical asymptote occurring here at x equals 2. So those are going to be pieces we want to pay attention to. So, domain. We are defined until we get to that vertical asymptote. We're going to have this hole in the domain where we just can't have x equals positive 2. So there's a few ways to write this. We could say x is all real numbers, and x cannot equal positive 2. So you could do is this overall, like x can be anything, and at the same time it can't be positive 2, something like that. We're going to see the same thing for our range, because we'll see it's defined until we get to y equals 1, where we'll have a horizontal asymptote where it's undefined, but then it goes on to infinity. So with this we could say y is between negative infinity and positive infinity, and y cannot equal positive 1. So that's how we can handle the gaps in domain and range. All right, last one here. This is going to be from a radical function. So domain, we're good until negative 3. So we're seeing everything from negative infinity up to negative 3. So for domain, we could say x is less than or equal to negative 3. That would be great. You could say negative infinity up to negative 3 and use a square bracket to include the negative 3. For range, starting at the bottom, this is all defined since it's going off to negative infinity, and then our function's going to stop at y equals positive 1. So we could say y is less than or equal to positive 1. Can do negative infinity up to positive 1, and then with a square bracket to contain it. So there are lots of examples and some different forms of how we can write the notation for domain and range.